So I'm starting with the deepest muscles on the posterior part of the leg. You can see where the tendons go. Let me set this down. Get a better grip on it. And then here, I'm gonna just move this out of the way. We have the deepest, which anchors kind of across this portion of the foot, which is connected to this larger muscle. And then these muscles here, so this one would be on the little toe, or not the little toe, the big toe. And then this one here would actually lift or move the tips of these 4 digits. And then once I finish connecting and securing these down, and then securing the 150-pound test fishing line, those will have the second part, which finish bringing the toe to its full flexion. And then, so this is the posterior part of the leg, posterior part of the foot. Once I have that done, we'll start doing the anterior part of the leg, the shin, and the top of the foot for the extensor muscles. And then, of course, we'll move up the leg. And once we get up to here, then, I'll attach this side of the hip bone. And then once this other leg is done, I can join the hip. Actually, I'll probably start working on the arms, because I want to get the limbs done first, and then I want to build the spine with, and you can actually see as I flex the foot. Yeah, so as I was saying, I want to get the spine done with all the fiber optic data cables built in. So as I join the limbs up to the spine, I can connect all the data points to the different parts of the body. So each limb will have its own series of sensory, so there'll be deep sensory sensors in this foot, there'll be a 5-way positional sensor on each of the large bones and the foot, acceleration, temperature, pressure, heat, and even perhaps an air sensor to detect leaks in the pneumatic system. All that raw data will get sent to a microprocessor to do the initial raw processing, and it gets addressed and sent to an AI chip further up the system that takes all the communication, and you can have reflexes built into the limbs. So if something's hot, the limb can pull away before the signal even reaches the brain, as well as doing any additional pre-processing on the sensory data before it goes to the brainstem and into the brain for final processing. And yeah, so as you can see the tendons. So even at their most relaxed, they still have a little give. And these balloons here, let me just kind of set that there. Whoops, of course. And here is a look at the type of bladders we're using. These are custom made. As you see, they're quite thick, made with balloon latex. I fiber reinforce them around the inlet to help on wear and tear. And these bladders can take up to 65 pounds or 65 psi I should say, per bladder. So they can actually exert quite a lot of force. I'm most likely going to make some thinner bladders for more fine muscles when it comes to designing the hand, so they can be smaller, go in smaller places to control the angles of the fingers, so that when we design the hand, it can manipulate tools very accurately. But yeah, so this is the start. I just thought I'd share. And so now, like I said, I have to get this muscle attached. Well, actually, all the tendon sheath attached. But yeah, that's it. Well, I know it had been a while since I'd given you guys an update, but this is where I'm at.